Good evening students. Today our topic of discussion is the difference between scalar and vector quantity. So I am going to give you the basic practical example regarding scalar and vector. Let's suppose any mass is given. Okay, let's suppose we have to purchase sugar. Okay, and let's suppose its weight is 2 kg. So here 2 is somewhat constant with its unit. Its complete term is called physical quantity, and every physical quantity is having some numerical data as well as its unit. Maybe unit is there or not. So this is what it is, magnitude of the physical quantity. So if any physical quantity is completely represented by its magnitude only, so that is called what? That is called scalar quantity. Okay, I am repeating again. If any physical quantity is completely described, completely explained by the help of its magnitude only, so that is called scalar quantities. All the scalar quantities having the same unit can be operated algebraically. Let's suppose if 2 kg weight is there and another 3 kg weight is there. So both the term having the same unit. So if two physical quantities are there having the same unit, they can be operated, they can be added algebraically. So if we are adding both this term, so we get the result is equals to what? 5 kg. So this is very important. The addition or subtraction is done between the same kind of the physical quantity, or we can say having the same unit. If two physical quantities are there which having the same units, so we can add or subtract them. So if any physical quantity having only magnitude, or it can be completely explained by the help of its magnitude, is called scalar physical quantity. Okay. Now our discussion is what is vector and what is vector quantities. So sometimes only magnitude does not give the complete information of any physical quantities, and we need somewhat the direction also. For example, I can just give you that example. Let's suppose any car is moving in a particular direction. Okay, one car is there which is moving with some velocity in a particular direction. Now if we want to just describe or explain its motion, so we needed what? Two terms. One is that how fast or slow car is moving and in which direction car is moving. So whenever there is a need of the direction of any physical quantity to explain it completely, so that physical quantity is called vector quantities. Means in the vector quantities having two terms, one is magnitude and the second one is particular direction. Without direction it cannot be completely explained. Let's suppose there is so many chances are there. No? Let's suppose car may be moving in the positive x direction, or we can say in the east direction, or this car may be moving in the north direction or west or south. So in which particular direction it is moving, it is need to know. Na? So that is why if any physical quantity which can be completely described by the magnitude and its direction is called vector physical quantity. This is the basic definition of the vector quantity, but there are some terms which you need to know carefully. Okay. Important criteria. Important point to be having a vector physical quantity is what? Magnitude as well as direction. And one more important thing is there, excluding these 2 points, that particular physical quantity, if the quantity is vector, so that physical quantity must have to follow the triangle law of addition as well as parallelogram law of vector addition. This is very important thing you need to know. This is the simplest criteria to having a vector, means the quantity must have magnitude as well as direction, but if the quantity is vector, so it must have to follow the triangle law of addition as well as the parallelogram law of vector addition. One important thing is there, you have to understand. Let's suppose if any physical quantity is there which having a magnitude and direction, but that particular physical quantity does not follow the triangle law of addition or parallelogram law of vector addition. So that particular physical quantity cannot be treated as a vector quantity and that will be scalar only. I am just giving you some example regarding it. Let's suppose current is there. We will further discuss that what is the triangle law of addition and the parallelogram law of vector addition in the next video, but here I am just giving you the basic difference between this scalar and vector, which generally understood by the only magnitude and direction, which is incorrect definition. The particular quantity must have to follow the triangle law of addition as well as the parallelogram law of vector addition, then only it will be vector. Okay, let's suppose I am just giving you example of the current. Okay, we all know that current having some magnitude as well as the direction also. Okay, as in the external circuit, the current flows always from the positive terminal of the battery to the negative end of the battery, and that having a particular magnitude also. For example, let's suppose I am just giving you a basic example. Let's suppose one wire is there in which the current is just flowing from A to B in a particular direction, having magnitude as well as the direction. But this current is not a vector quantity, which is very important thing. Current is not a vector quantity. The reason behind it, the current does not follow the triangle law of addition and the parallelogram law of vector addition. So here this current having a magnitude as well as direction, but these two laws not has been followed by this physical quantity, that's why we cannot say is vector. So it's generally a scalar. Some other example also, like pressure. Pressure is also a scalar quantity because it does not follow the triangle law of addition and the parallelogram law of vector addition. Now we have to understand that what is these two laws. Okay, so these two laws I'll discuss later. I'll just give you the basic representation of the vector, that how to represent a vector. Okay, representation of the vector. Vector is represented graphically by the help of the arrow. It having two ends, one is tail portion and the arrowhead is head portion. Okay. Vector starts from the tail and ends to the head, and this particular length of this arrow gives the magnitude of the vector. If any, let's suppose I'm just writing any vector. So if A is there, okay, and if I am applying an arrow on this particular letter, so it represents the vector. So whenever there is a vector representation, so always use this vector sign on the head of any letter. Sometime vector can be represented by the bold letter also. So these two representation of the vector you need to know at how to express it. Okay, So this is the representation of our vector. You need to remember it. Now there is some operation of the vectors also which you have to understand also. Algebraic operation. In algebraic operation, we are going to discuss firstly the addition of the vectors. I am relating this term with the practical example. Okay. So let's suppose one block is there. Okay. Let's suppose one block is there which is placed on any maze or table. Okay. So I am going to applying some particular force in a right direction, and let's suppose this particular force is F1. Okay. Again I am applying another force F2 in a same direction. So these two forces are applying on same block in a same direction. Okay. So these two forces will be added in a vector manner, and that is called vector algebra. Means if you need to find the total force or the resultant force which is applying on this particular block, so that particular force will be what? It will be F1 plus F2. Okay. Now same example I am just taking, but I am just changing the direction. Let's suppose same block is there, but this time I am changing the direction of F2. Let's suppose F2 is applicable in an opposite direction of F1. So now if, let's suppose if the force is not vector quantity and if it is only scalar quantity, so in a scalar quantity we have to just simply add. There is no meaning of the direction, but because force is a vector quantity and it having a direction, so according to direction we have to determine that whether we have to add or subtract or what we have to do for finding a total or the resultant result. For this particular case, now we need not to add these two forces because the direction is opposite. So for this, the resultant will be due to the difference of these two forces. Here the resultant force will be the difference of F1 and F2, which will be greater, that will be subtracted from the other one. Okay, and that particular resultant force will be applicable in the force which having a greater magnitude. So this is very important, you need to know which force having a greater magnitude, so resultant will be in the same direction of the greater magnitude force. Okay, so now addition of vector by the graphical method you have to see. As earlier I just told you that every vector is represented by the arrow. Okay. So let's suppose this is our vector A. Okay. And other vector I am just taking vector B. This is the direction of vector A and this is the direction of vector B. Now let's suppose if we need to add these two vectors. So these are some points you need to remember. Whenever we are just adding the vector by the help of the graphical method, so always we need to add the head of one vector to the tail of another vector. This is very important thing. Always we need to add the head of one vector to the tail of another vector. So means if I am adding these two vectors, so it will be like this is our vector A and it is a head and this is the tail of vector B. So here from head to tail we have to add this vector B. This is very important. At a contact point always the head of one will be added to the tail of another. Okay. So now if we need to find the resultant force or resultant vector, so for the resultant case, always the closing side of these two will be the resultant, and the direction of the resultant will be always from head to head and tail to tail. Means the resultant head will be towards the head of this one and resultant tail will be added to the tail of vector A. So this is very important, you need to understand also that always for the addition, in normal addition we have to add head to tail, but for resultant vector we have to add head of the resultant to the head of the vector and the tail of the resultant to the tail of the another vector. This is very important, you need to understand it. For the normal addition we have to add head to tail, but for the resultant, now just see here, let's suppose by mistake I am just doing this, okay. So now here this head is, this is its tail point and this is the head point of the vector. So now we are just doing, if we are doing this, so this is the wrong manner. Always the head of the resultant vector will be towards the head of the vector and tail of the resultant vector will be connected to the tail of the particular vector. This is very important. Whenever there is any symmetry or any figure is given, so always the resultant vector will be the closing side of that particular figure, whether it is a triangle or any other polynomial. So this is very important and you need to understand also. One more important thing is there. Okay, another example I am giving you by which you can understand that how to add two vector graphically. Let's suppose these three vectors are there and we have to add them algebraically. So how to add? What I have told you earlier, that in the normal addition we have to add head to tail. What? Head to tail in a same manner. So just join, this is our vector A which will be connected to the tail of the vector B. So at the point of the connection, just see here, at the point of the connection, the head of one and the tail of another should be there. Getting? So this is our vector B. Now from vector B we have to add this vector C also. So this is the connection point where we have to add the vector C. So just see here. And the direction of here also, this is the point of connection. And this is also a point of connection. So at the point of connection we have to add head and tail, one of the head, another of the tail. So this is our vector C. This is our vector A, it is vector B and it is vector C. Now these three are added and we have to join the resultant vector. What we have to do? We have to join the resultant vector. So what I have told earlier, for joining the resultant vector, always the head of the resultant vector will be towards the head of one end and the tail of the resultant vector will be towards the tail of the another vector. So just see here, if arrow is towards right side, means this denoting the head and this point is denoting the tail. And let's suppose for this vector C, it is denoting the upward direction, means this is head and it is tail. So for resultant vector will be the closing side of the particular figure or the particular polynomial. Getting? So I am just joining, it must be straight, this is very important. So now we have to add tail to tail and head to head for the resultant. So the direction of the resultant will be like this. So this is a resultant and that will be the sum of this vector. So this is our algebraic operation and very basic operation in which we have to just add algebraically all the vector. So simply for the addition of the vector we have to use head to tail operation, and for the resultant we have to add the head of the resultant to the head of one vector and the tail of the resultant to the tail of another vector. Always this is very important. If you are doing mistakes, so definitely the question will be wrong. Okay. So like this we have to just add. There are so many operations also like subtraction and the product rule. So that we will discuss later. Okay. Thank you.